In this video we're going to look at completing the square when our middle term is odd, which creates a problem because we're going to have to deal in fractions or decimals. So let's have a look and see what I mean. So if I go through my completing the square method, write down the first two terms, normally what happens now is I halve my 9, square it and add it on. Now if I halve 9, I can either leave it as 9 on 2 or I could write it as 4 on 5. 4.5. Now think about the fact that we then have to square it. I would much rather square 9 over 2 than I would trying to work out 4.5 squared without a calculator. So I'm going to just add 9 on 2 squared. I'll worry about what that equals in a second. So I've halved my coefficient of the middle term and squared it, added it on. Now I take it away and tack my minus 3 onto the end. This now becomes here my perfect square, there to there. So I have the square root of x squared goes here. The square root of 9 on 2 squared, well that's just going to be 9 on 2. So by leaving it as a fraction there, by leaving it unsimplified, it makes this bit a lot easier. My plus 9, so the plus there becomes the plus in the middle, squared, take away. Now 9 on 2 all squared is actually just 9 squared on 2 squared. And then I take 3. So the completing the square bit is actually quite simple. Just leave it as a fraction. Don't try anything fancier than that. Leave it as that. Now we have to neaten this up. I've got minus 81 on 4. And I have to take away 3. Now, when I'm subtracting or adding fractions, I need to have a common denominator. So I need to think about how can I express 3? Instead of 3 over 1, I could make that 12 over 4. Keep going. We've dealt with this, but it just comes along for the ride here. Minus 81, take away 12 is minus 93, all over 4. And then we've got two terms separated by a minus, one of them squared. I need to try and dots this. So let's write this as square root 93 on 4 all squared. Continuing on, I've got this minus, now what I'm going to do here, I've actually recognised that root 93, I can't do much with that, but the square root of 4 is actually 2. So let's, instead of writing it as root 4, let's write it as 2. And you'll be able to see why I do that in just a sec. So I've gone this one minus this. Now I've got this one plus root 93 on 2. Now if you were to do this, if you're doing this out of the textbook and you go to check your answer, it's still not going to be correct. What the next little step you need to do is that recognise that you've got adding and subtracting fractions, you've got a common denominator, you could combine that all into one. So I'm going to x plus 9 take root 93 on 2, and then this one is x plus 9 plus root 93 on 2. So they've just combined those two fractions because there's a common denominator. Let's have a look at this one over here. We're going to do the same. Don't be scared of this thing here. It's already a fraction. We know how to deal with fractions. We're just going to do what we've done over here. Get a common denominator, add or subtract them. So let's complete the square. X squared, take 5x. Now I need to halve my 5 and square it. So 5 on 2 squared, I add it on, take it away, and then the minus 3 on 2 gets tacked on the end. Okay, here's my perfect square, there and there. So that one there is the x from here. The square root of 5 on 2 squared is 5 on 2. This minus comes down. Then I've got minus 5 squared is 25. 2 squared is 4. Take 3 on 2. So I have x minus 5 on 2 squared minus, now this one here is over 4, so let's write this one over 4. Double the denominator, double the numerator. X minus, just keeps being the same. Minus 25, take away another 6 is minus 31 on 4. And I'm going to write this as a third and just finish it off. So I have a dot x minus 5 on 2 minus root 31 on 2 x minus 5 on 2 plus root 31 on 2. The 2 coming from the fact that I've square rooted before, and then it was x minus 5 minus root 31 on 2 x minus 5 plus root 31 on 2. Common denominator, we just add or subtract them to put them onto one fraction. Good luck.